you're interested in a real fungi, look no further, because representing team faculty, we've got Dr. Michelle Momany, and she will be talking to us today about exploring the septon cytoskeleton in a fungal model system. Right?
I gotta correct you though. I'm a fun gal. So the cytoskeleton is a series of scaffolds inside of the cell, and these scaffolds support the cell, they shape it, and they help organize all of its activities. Septons are a really recent discovery that play a part in this cytoskeleton. Now it turns out that humans have septons in virtually every cell of the body. When septons are missing or damaged, there's several diseases that can result, and those are symbolized by the ribbons up in the top corner. So leukemia and lymphoma, Alzheimer's, bipolar, schizophrenia, all have been associated with damage to the septons. We don't know if damage to the septons is causing these diseases. We don't actually even know how septons are organized or what else they interact with in the cell. Trying to figure out what septons do in a human is a little bit like trying to figure out what steel does in the world's tallest building. The Burj Khalifa, pictured over in this corner, is 2,700 feet tall. It's 163 stories, and it has 55,000 tons of steel. Probably not the simplest place to figure out what steel might be doing. Enter the humble fungus. Yes, bread mold, shower curtains, toenails, that kind of fungus. In the bottom center here is Aspergillus, the fungus we work on in my lab. And fungus is to human as cottage is to the Burj Khalifa. Smaller, simpler, but they have many of the same basic systems. So in one set of experiments in my lab, what we did was take a green glowing tag and add it to a septon. And you can see that result here in the center. In the same way that a string of Christmas lights will show you the position of a roof line, this tag shows you the position of septons within the cell. And what you see in this particular example is a very young fungal cell with one tube coming out, and the septons are forming rods along the outside of that tube. In another series of experiments, we took septons and removed them from this fungal cell. We expected that the cell might collapse, but what we saw instead is pictured in this bottom corner. Instead of seeing just one tube emerging from this young cell, we now saw multiple tubes emerging. So we're working right now on trying to understand how the loss of a septon is leading to uncontrolled growth in this fungus. And we think that understanding this will help us better understand the connection between septons and uncontrolled growth in human diseases like cancer. Thank you.